Welcome to the Let's Talk Data podcast series presented by SAP, where we explore game-changing technology and strategies with leading experts with the goal of maximizing the value of data across your organization. If you haven't done so already, please follow or subscribe to our podcast on your favorite channel to stay tuned in.
Hello, everyone, and welcome to this episode of Let's Talk Data podcast series, where we will discuss data integration with focus on SAP S4HANA Cloud. My name is Michael Sanjongco, and I'm from the SAP S4HANA Cloud product management team with focus on analytics and data integration. Today, I'm joined by my colleague, esteemed Torsten Kamenz from the S4HANA architecture team. Hi, Torsten.
Hi, Michael. Hello to everyone from my side as well. I'm happy to join today to spend some time on data integration in S4HANA Cloud and provide an overview of the data extraction options.
Okay, thank you, Torsten. It's always a good start with the basics to get the foundation and background. So, Torsten, can you please talk briefly about the differences between data integration or data extraction from the classic SAP ERP standpoint versus how it is now in the SAP S4HANA Cloud or even on-premise? And what is, for example, a virtual model and its relationship to ABAP core data services? And what's the motivation behind it?
Yeah, happy to do so. But a large list of topics, so let's try to focus a bit here. So basically, the main driving scenario behind the data extraction capabilities in S4HANA Cloud is to provide mass data to external data warehouse solutions like SAP BW or SAP Data Warehouse Cloud. Of course, data extraction isn't restricted to these data warehouse scenario, and also other scenarios can be supported, which need extraction of data to applications or data platforms. Before S4HANA Cloud, in the classic SAP ERP, there have been these BW extractions, so extracting data to the business warehouse, using specific extraction options like BW extractors and other development objects. And in addition, in an on-premise setup compared to the cloud, there are also other options to extract data out of a system. As a customer has large control over these systems and so can use these different options. An example for data replication here would be the SLT solution, which replicates data on table level into another database, for instance. But with the move to the cloud, this needed to be changed as the cloud system is managed by SAP, so by the provider of the cloud solution now. Of course, we need to guarantee stability of the extraction solution, of the extraction interface to the consumers, and have a controlled set of extraction options which guarantee these stability feature and which also support key user extensibility and other features. And that's where the virtual data model now comes into the picture. The virtual data model in S4HANA is the central common data model of data in S4HANA for a huge set of different scenarios like UI applications, like integration, like search, and as well for like data integration, data extraction. The virtual data model ensures that there is a common and understandable terminology on top of the data, and providing the data in an easy to understand way by the consumers. Technically, the virtual data model is implemented as CDS views. CDS stands for Core Data Services. And you can think of CDS views as something similar to a standard database view, so providing a select statement over one or different tables, doing some projections. And in addition, providing additional metadata via annotations and associations, which tell the system a little bit about the data and how to work with the data in different scenarios. And the CDS views, they also do what I mentioned before, this renaming of the technical fields to common naming conventions to make the data consumable by external consumptions. And these CDS views are also now used as a basis for the data extraction. So there is a specific set of CDS views which are enabled for data extraction. In principle, this is just done via adding one annotation which defines that this view is intended to be used for data extraction. And then the extraction runtime can use this view to extract the data. In addition, there's also a stability contract assigned to such an extraction view in order to guarantee that this extraction view is not changed in an incompatible way with a later release, so that the consumer of the extracted data can rely on the stability of the interface. And yeah, I said these CDS views, these extraction views are now, they are executed by an extraction framework, which is running inside of the SAP S/4HANA system. And for instance, a consumer like SAP BW can then use this to extract the data via the CDS views. And in fact, the framework which is being used here is the traditional ODP framework, which was also used to do the data extraction via the classic BW extractors. Now, on top of this, we have then different APIs for the different clients, like BW, like DWC. But the basis is really the set of extraction views which are provided for all the application areas within S/4HANA.
Okay, thanks, Torsten. Now we have the background and the basics and the foundation of how to extract data out of SAP S/4HANA Cloud. And before we touch on the APIs and protocols that you mentioned, do you mind briefly telling us what are the general ways or capabilities of extracting data from SAP S/4HANA Cloud?
So we have to distinguish here, I guess, two main scenarios how you would extract data, which is the full and the delta extraction. So basically, full extraction means you extract all data from, for instance, one table via an extraction view into the consumer. So you do a full load of all data at the point in time you are reading the data from the system. Compared to that, we have delta extraction, which is a variant where you only are interested in the delta of the data since you last requested the data. So you really ensure that you are always up to date with the S4 system with your data. The full data extraction is provided by each and every extraction view. So it gives the consumer the possibility to extract all data, to do a full or initial load of the data into the consumer. Of course, this initial load, this full load of data could comprise a huge set of data. It could be billions of entries in a table which need to be extracted. And so the framework here supports for the full extraction also a stable load via packages. So you can define in which package size you want to retrieve the data, and then the system guarantees that the data are fetched in these package sizes in a stable way, so that you don't lose any entry. Of course, in addition to the full extraction, there is a necessity to be able to also do a delta extraction, as for the really big tables you don't want to read again and again the complete data set when you are only interested in the changes, as you already have read the full data set some time ago. And that's where now the delta extraction feature comes into the game, which allows just to extract the data which have been changed since the last request of the data. And technically, this is done internally in the system by using database triggers, which store the changed entries in some logging tables, and then the extraction runtime can take these changed data sets and provide them to the consumer of the data whenever the consumer requests the changes. This feature is not available for each and every extraction view, because there are extraction views which only work on very, very small data sets. So it's not really needed to provide some data logic here, but especially the data extraction views for the big transactional data sets, they should typically be supporting data extraction.
Great. Thank you, Torsten. So I guess they could also find these CDS views for data extraction through the view browser, right? With the right metadata, with the data extraction annotations and things like that, right? Yeah.
Yes.
Great. Thanks. Now that we know the different capabilities, or the two capabilities of how to extract data out of SAP S/4HANA Cloud, now let's talk about some of the use cases or reference architecture in regards to extracting data to different target systems or consumers, such as, as you mentioned, SAP BW, Data Warehouse Cloud, or even using data intelligence or HANA database. Can you touch on how these consumers access the data from SAP S/4HANA Cloud?
So the basis for all of these consumers to access the data within the S4 system, or to extract the data, to be precise, into their own storage, the basis is always the extraction data, extraction views, and the extraction framework on top, which handles delta and full load and so on. And then on top, there are different APIs provided for the different scenarios or consumers. We have specific consumers who, of course, have different requirements regarding APIs. We have a set of APIs which typically use different protocols. And one important point here is, if we speak about APIs and protocols in S/4HANA Cloud, is just to mention the term communication scenario. So in S/4HANA Cloud, all the APIs which are available for integration to an S4 system, like for instance in this case the data extraction, are managed via a so-called communication scenario, which is the object which a customer needs to activate in his system, and then the corresponding APIs or services which are collected in the scenario become active and can be used via a defined communication user to access the interface. And that's also the case for the data extraction. And I will mention the relevant communication scenarios. They have specific numbers when we now go through these different APIs, just to make sure that it's clear that there is always a specific communication scenario for a specific communication channel. So let's then come to this APIs, this channels, and of course the first and one of the really important consumers and scenarios is the extraction of data from an S/4HANA Cloud system into SAP BW. And as said, the framework which is used for data extraction is the already existing the traditional ODP framework. So it's quite natural that the interface here relies on the same technology like the BW used in former times for the ERP system. So it's based on RFCs, which in the case of the cloud solution have been wrapped into web services. And here we have the communication scenario SAP COM 42. And if this is active, then the web services on top of the ODP are active in the system, and the BW system could create a connection to this web services of the S/4HANA Cloud system. And then in the BW system, one could set up the corresponding data sources, define the data transfer process, define if only an initial load or delta load is wanted, or So managing the whole data extraction process from S/4HANA Cloud into BW using this API. But this API, this IFCs which are wrapped into web services are really very specific for BW. And we have new SAP consumers like SAP Data Warehouse Cloud, SAP Data Intelligence, and also they should be able to extract data from S/4HANA Cloud. And here we have now a new interface which is called Cloud Data Integration, CDI, to extract data from an S4 system. This is the communication scenario 531. The CDI services are generally, these are standard OData services. So it's really a standard OData protocol. And on top of the OData protocol, CDI provides some additional specific features which are needed to support the qualities of data extraction I mentioned in the beginning, like a packaged, stable packaged full load and the delta load. So all of this is included in these CDI services. So Data Warehouse Cloud and the Data Intelligence can use this scenario, these CDI OData services, to extract data from S/4HANA Cloud. And once the corresponding communication scenario is set up, for each of the extraction views, a specific CDI OData service is active in the system and can be used. And then in addition, a new API or channel available for data extraction, which is working in the context of the data intelligence pipelines. And it's called the SAP, the ABAP pipeline engine, or APE. In here, the pipeline of the data intelligence is somehow extended into the ABAP system. And via this mechanism, the pipeline engine can access the extraction views and extract the data into a data intelligence pipeline, and then the data could be processed however the pipeline is modeled. The advantage of this protocol compared to CDI is that it has a better throughput, as the protocol is more efficient than the OData services. The communication scenario is 532. And as said, this ABAP pipeline engine as the execution engine of the pipeline, or as which organizes the execution. So all SAP products which contain or which make use of data intelligence pipelines can use this channel. So which means, first of all, of course, data intelligence standalone. So data intelligence standalone could be connected to an S/4HANA Cloud system. And in addition, other SAP products or solutions like Data Warehouse Cloud are currently, or the pipeline engine is currently being integrated into these products, so that Data Warehouse Cloud could use the pipeline engine as channel to the S/4HANA system. These are the current three different channels which are available in an S/4HANA Cloud system to do the data extraction based on the defined set of extraction views in the system.
Nice. So sounds like customers have different options depending on their scenarios. So, all right. So lastly, Torsten, I know listeners are always wanting to hear what's upcoming. So can you tell us if there's any features that you can discuss that's upcoming in regards to data integration?
Yes, one of the most prominent features or requirements for the data extraction was to be able to create own extraction views by customers. That's in the very beginning. I spoke about the extendability of a cloud solution being supported on top of the CDS views. And currently, it's not possible. There's a restriction that a customer can create an own extraction view via this key user extensibility. And this gap should be filled very soon so that customers are able then to create own extraction views on top of their own data or on top of other released CDS views in the system.
Wow, great, Torsten. Yeah, seems like a lot of customers are looking forward to that feature. So thank you, Torsten, for your time and sharing your expertise and knowledge. We really appreciate it. Thank you as well to our listeners. Please check back in the near future for further discussions of each of the use cases that Torsten talked about in details, such as data extraction to Data Warehouse Cloud or through data intelligence. Torsten, thanks again. Any parting remarks to our listeners?
Oh, thanks from my side as well. And you're hoping to speak to you soon about some more details of the different aspects of data extraction.
Thanks again. And this concludes this topic of Let's Talk Data podcast series. See you soon.
We hope you enjoyed the podcast. Check out the show notes for additional links to information. And please subscribe or follow to join us on the next episode of Let's Talk Data presented by SAP.